In this final session about what makes an API a REST API, we're going to talk about client and server decoupling, cacheability, code on demand, and statelessness. First, we have the client and server decoupling constraint that establishes that there is an independence between client and server. The client shows the user interface and the server is in charge of the database and business logic. So the REST API sits between the client code and the server code. So in order for the client to communicate with the server, it has to go through HTTP methods. And in order to have the server communicate with the client, we go through an HTTP response. So we can actually change the code here on this side, on the server side. We can change function names. We can change the order of parameters for functions. We can even change the complete language in which we're building the business logic at the server side, and we are not going to break the client side code. Then we have the cacheability constraint that establishes that the responses coming from the server define whether they are cacheable or not. So caching devices may be used. So let's say that the user executes a get operation on this particular resource, and the response coming back from the server establishes this header, cache control public with this age. So this intermediate device here, this cache server, is reading these responses. It is going to detect these, and it is going to reach the conclusion that it is going to store this data in its database. So after doing so, future requests for this particular resource coming from this client or from other clients are going to be intercepted by the web cache server, and the web cache server is going to reply back using this information that is stored in its database previously. So we are going to offload some load from the REST API server by using cache servers. Perfect example of data that is suitable to be placed on a cache server is catalog data. When we have a catalog, usually the catalog of the items that we sell within a business don't change for months. So we can store that in a web cache server. And we also have the optional constraint known as code on demand, where if the client requests so, the REST API server may reply back with executable code, for instance, JavaScript applets or compile components. And then we have the statelessness constraint that establishes that REST APIs are stateless in nature. In other words, servers are not going to store session context or history information on the server side. So we are not going to have a database on the server side storing session context or history for clients. For instance, if we want to maintain session information, we can store that on the client side. That is allowed. We are going to talk about stateful and stateless APIs in the following session.